This is an interesting picture. This actually shows what is resistance, what is the meaning of resistance in a very interesting manner. You can see that the current, this is the current I have shown here. This is the current flowing through a conductor. Conductor is this tube like thing, and in order to flow, in order to make the current flow, you know we need a potential. So this man is the potential who is pushing the current, and see how the resistance is standing here. So the resistance is trying to obstruct the flow of current by tying him up. So resistance is actually an obstruction that hinders or will hinder the flow of current. So today we will learn more about resistance. We'll start the theory now. Resistance. This is our fourth class on current electricity. Those who haven't seen the previous three classes, the link for those classes are given in the description box. Please go through that for better understanding. So today we'll see about resistance. So as you know, the meaning of resistance is obstruction. So if something is being obstructed, we say that there is a resistance. Now we are learning about current, and the current will be flowing through a conductor, maybe a metallic wire or any conductor. So when the current is flowing through the conductor, if the conductor is offering some obstruction for the flow of current, or if the conductor is hindering the flow of current, then that is known as the resistance given by the conductor, or the resistance of the conductor. So the obstruction which is being given by the conductor on the flow of current, we name that to be the resistance of the conductor. So when you are defining the resistance can be defined as the obstruction offered to the flow of current by a conductor is called its resistance. So this is the definition of resistance: obstruction offered to the flow. So when current is flowing, if conductor is offering certain obstruction, then we name that to be the resistance offered by that conductor. Now let us see why this resistance is there, or what is the cause of resistance. For that, let us take a conductor, maybe a wire, metallic wire. So inside, since we are considering a metallic conduction now here, the conduction is due to electrons. That is, the flow of electron will give rise to the current. So we are taking metallic conductor now. So inside a conductor, we have positive charges, that is, positive ions are there, and we have electrons. Positive ions are there, and we have the electrons, and the movement of electron will constitute the current. So electrons are there. So in metals, you know that the electrons are free to move. So the electrons are free to move throughout the surface of the metal. They won't escape from the surface, but they will move inside the metal. And these electrons which are free to move, we name that to be free electrons. And free electrons are responsible for the conduction, or for the flow of current inside a conductor. The free electrons free electron movement will produce the current. So the inside a conductor, we have positive ions. These positive ions are stationary, they won't move, and the electrons are the ones who are moving. And if we are not connecting the wire to any cell, then all the electrons will randomly move in any direction. and as a result they don't have a definite direction of movement. If one electron is moving in this direction, the other may be moving in another direction. So there is no arrangement for the movement of electron. They are in a the free electrons are moving randomly inside the conductor. So they don't have a particular direction of movement. If one electron is moving in one direction, the other electron may be moving in another direction. So all the electrons will be randomly moving inside the conductor, and all the positive charges, they won't move, they will be in their own position. So since these electrons are moving in random manner, that is if one electron is moving in this direction, the other may be moving in the other direction, the other may be moving in the opposite direction. So all together, when you are considering, all the electron movement will get cancelled, and net effect is they behave as if there is no movement of electron. That is why in an ordinary conductor, that is when we are having a conductor, even though the electron movement is there, free electron movement is inside the conductor, we don't say that the current is flowing through the conductor. That is we don't feel the current inside a conductor, which is simply kept. If a metal piece or a metal wire is simply kept, we don't say that a current is flowing through the conductor. But inside that conductor or a metallic wire, electrons are moving, but it is in a random manner in different direction. So one movement may be cancelled by the other movement, and so net effect is does not produce any movement of electron in one direction to provide a current along a direction. So that is the case of ordinary conductors which are not connected to a cell. Now if and also while they are moving, that is while these electrons are moving, they will collide with the positive charges. When they are moving randomly, they can collide because positive charges are fixed at their position. So when the electrons are moving, they will collide with the positive charges. So this collision actually is responsible for the resistance of the conductor. The collision means it is opposing the movement of electron. So the collision between the electrons and the positive charge is one of the reason for the main reason for the resistance inside a conductor. Now let us see what will happen when we are giving a connection to a cell. That is, I am going to connect the same conductor to a cell. So we have the conductor here. As indicated earlier, we have the positive charges which are fixed at their position, and we have the electrons. I'll show the electrons later, and the electrons were in random movement inside the conductor. Now I am going to give a cell connection. That is the positive of the cell is connected to one end and the negative is connected to the other end. So before the cell connection is given, the electrons were in random movement. No one was there to control the movement of electron. They can move in their own way. They were independent. They were very free. Now there is somebody to control them, that is the cell. Okay, so one positive potential is there and one negative potential is there. So electrons are negatively charged particle. So what will happen? The electrons will be attracted towards the positive side. So all the electrons inside the conductor, that is all the free electrons inside the conductor, will align themselves along the direction of positive charge, or they are forced to move towards the positive charge. So now somebody is there to control. So all of them will be disciplined. So they all will move in one direction only now, that is towards the positive terminal of the battery. So since all the electrons are aligned in the same direction and the electron starts flowing towards the positive side, a current is created. That is why when we are connecting to a battery, a current is flowing through the conductor. But during the movement of the electron towards the positive side of the cell, they will collide with the positive charge, that is the positive ions inside the conductor. Positive ions are there. So while these electrons are drifting or moving through the conductor, they will definitely will collide with the positive ions inside them. Okay, even though they are accelerated, I mean, even though the cell is helping them to increase their speed, due to this collision or when they are colliding, their speed will decrease, or they won't get an acceleration, or they will slowly drift towards the positive end, or the current will a current will be produced inside the conductor, but that current will be getting a resistance. Why this resistance is happening? Because while the electrons are moving through the conductor, they will collide with the positive charges, and this collision will offer a resistance for the flow of electrons, or offer a resistance for the flow of current. So you can understand that if more collision is there, what will happen? If more collision is there, we can say that resistance will be more. Okay, because resistance is the hindrance or the obstruction. So if more collision is happening, it means the resistance offered will be more, or less current will be flowing, or the current there will be more difficulty for the current to flow if more collision is there. So that is about the relationship between the collision and the resistance. So the main cause of resistance is the collision between the electrons and the positive ions which are inside the conductor. Now let us see what are all factors will affect the movement of affect the movement of electrons, or what are the factors affecting the resistance. What are the factors affecting the resistance? Now the most important, or the first factor affecting the resistance, will be the nature of conductor. Nature of conductor. So nature of conductor means with what material the conductor is made. Conductor means those material through which the current can pass. So there are different types of conductor. For example, silver is a conductor of electricity. Then copper is a good conductor of electricity. Aluminum is a conductor of electricity. Then lead is a good conductor of electricity. All the metals are actually good conductors of electricity. But when you look at the conductivity, or when you look at the amount of current flowing through these, there will be difference, because silver is not same as copper is not same as aluminum, or it is not same as lead. So the materials are different, the number of electrons are different, their electronic configuration is different. So according to the amount of electron, or the electron concentration, these materials are different from each other. So the resistance offered by them will also be different. That is, resistance of silver will be different from resistance of copper. The aluminum will be having a different resistance compared to lead. So these materials, even though they are good conductors of electricity, their resistance will be, or the conduction level will be different. So those offering less resistance, those material which offers less resistance, they can be called as very good conductors of electricity. Very good conductors of electricity. So those having less resistance will conduct electricity more, or through that material the current will flow more. Okay, so less resistance means more current will flow through that. Now the second factor on which the resistance depend is the length of the conductor. Length of conductor, or the length of the wire through which the current is flowing. Now I'll take two wires of same thickness. So this is one wire, same thickness. This is another wire. So let this be length 1 and length 2. Seeing the figure, you can see that length 2 is greater than length 1. So when we are taking a small length, the electrons, and if it is connecting to a cell, positive, and this also same voltage is given, cell is given. Okay, so the electron in this case will be drifting towards this direction. Here also the electron will be drifting towards this positive terminal. Here is a positive, this is negative. So the electron will flow towards the positive terminal. So when the length of the conductor is less, the electron need to travel only a short distance. So if the electron need to travel only a short distance, the number of collisions will decrease. That is, it need to collide only with a small amount of positive charge within this small length. So if length is less, the number of collision will be less. But if length is more, if we are having a long conductor, when it is traveling a longer distance, it will have to collide with more and more positive charges on its way. So the number of collision will increase. If collision increases, resistance will increase. For better understanding, you just you consider that you are traveling through a crowd. So many people are there and you are traveling in a very narrow tunnel like thing, and this is a same narrow tunnel, but you are going to travel a long distance. So people are there, crowd are there. So if you want to travel through the crowd, then you will collide with the crowd. Okay, so if you want to travel only a short distance, then the number of collisions that you make will be less. Okay, so the resistance which you have to make, okay, will be less. That is, you can easily flow through, because the length you have to cover is very less. But if you have to cover a long distance, so you will be colliding with all these people, number of collision is increasing. So the resistance which you are suffering will be more, or it will be difficult for you to traverse this distance. Okay, more resistance will be there for you to travel such a long distance. Same is the case of current also. That is, if length is more, you will have to travel, or you will have to cover more collision. More collision will be there, and if more collision is there, then what will happen? More resistance will be offered. So if length of the conductor is more, the resistance of the conductor will also be more. Or you can say that the resistance is directly proportional to the length. Directly proportional means if one increases, the other will also increase. So that is the relationship between length of the conductor and the resistance. Now the third factor that determines the resistance is the thickness of the conductor, or we can say area of cross section. Thickness or area of cross section, cross sectional area. Cross section of the conductor. So let us consider two conductors. This is a thin conductor of same length. I am going to consider a very thick conductor of the same length only. Here maybe length is a little bit different, anyhow. So this is the area, this is a small area of cross section, and this is a very big area of cross section. Now our electrons are moving. The electrons are moving through a small area. This is a restricted, very small area. What will happen? The positive ions are already there. So since it needs to travel through a very narrow area or a very small area, it don't have enough space for traveling, and the number of collisions will increase. So what will happen? If number of collision increases, then resistance will also increase. Whereas in this case, here it is a very large, there are more area, the area of cross section is more, so more space is there. So the electrons, even though they travel in the same way, they have space, and the collision, if more space is there, the chance of collision is less. So the electrons can easily pass through the area without much collision. So if collision is less, then the resistance will be less. Okay, now just consider the case in which you are traveling through a narrow street and a very wide street. So crowd is there in both the cases. Crowd, people are there. So people are crowded street or crowded tunnel or whatever. So you are going to travel. So since it is a very narrow tunnel and people are obstructing your path, then you will have to collide with all these people and you will have to resist all of them. So your resistance will be more. You have to resist more because the area is more collision is going on. You have to resist more. If the area is more, that is, if you have more space, you can easily skip all the collisions and your movement will become easier. That means you have only less resistance. Same is the case of current also. If area is less, more resistance, so current will be restricted or resistance it will offer obstruction, more obstruction. If area is more, current can easily flow, the resistance will be less. So that is the relationship between resistance and area. So we'll write it once more. If area is more, resistance will be less. Why it is happening? Because less number of collision. Less collision is there because more space is there, so less collision, therefore resistance is less. Suppose area is less, what will happen? The resistance will be more because more collision will happen there. No space, so more collision of ions and electrons and ions will happen there. So in general you can write resistance is inversely proportional. One increases, the other decreases. So inversely proportional to area. So that is the second relation, length and area. Length is directly proportional, area is inversely proportional. Area can, the value of area depends upon the area of cross section. If it is a circular cross section, then area will be pi r square. It depends on the cross section, shape of the cross section. So that is about the dependence of area. And the last factor that determines the resistance is the temperature of the conductor. Temperature of conductor. Okay, you know, if more temperature is there, more energy is there, more heat is there. Now if more heat is there, kinetic energy will be more, or energy will be more. More temperature means energy will be more. So if more energy is given for the electrons, so when we are when the conductor is being heated or when the temperature of the conductor increases, what will happen? The energy of these electron will increase because they are getting heat energy. They are getting energy, so the energy of these electron will increase. The energy of the positive ions inside it will also increases. So as a result, when somebody is having more energy, they will be restless. So the positive ions, they will start vibrating. Initially they were in the state of rest, now they will start vibrating. They won't move anyway, they will start vibrating in their own position, and these electrons will also vibrate vigorously. What will happen then? Then the number of collision, when everybody is vibrating, what will happen? The number of collision, there is a more chance of colliding with each other. All are rushing or all are moving, so the chance of collision is more. So here more collision happens, then what will be the result of resistance? More collision means more resistance. So when temperature increases, more collision happens because the energy is being imparted for the electrons as well as the positive ions. So more collision will happen, and then the resistance will also increase. So to conclude, what can we say? When temperature increases, more energy will be imparted for the electrons and positive ions. So positive ions and electrons will start vibrating and they will collide with each other frequently. Or more temperature, more collision will happen. So if more collision is there, what will happen then? More resistance. Okay, so temperature increases means resistance will also increase. So that is the relationship between temperature and resistance. They are also directly related. Temperature increases, then resistance will also increase. So these are the factors affecting the resistance. We'll just conclude that the factors are: first one is the nature of conductor. Nature of conductor will depend upon the material. Different materials will be having different amount of electrons. So concentration of electron changes, conduction also changes. Some materials will be good conductors, some materials will be bad conductors of electricity. So through good conductors more current will flow, through bad conductors only less current will flow. That is the nature of conductor. Second factor is the length of the conductor, and we saw that if length increases, the resistance will decrease, because more length need to be covered, more collision will have to be suffered, so resistance will be less. Or resistance is directly proportional. Sorry, I wrote a mistake here. More resistance. Length increases, resistance will be more. Okay, so resistance is directly proportional to length. Now the third factor, that is about the area. Don't simply write area, it is area of cross section, or you can say thickness. Thickness of the conductor. What is the relation? If area is more space will be there, less collision, so resistance will be less. Or we can say resistance is inversely proportional to area of cross section. And the last factor is the temperature of the conductor. If temperature is more, resistance will be more, because more collision happens due to the more energy attained by the positive ions and electrons. So these are the 4 factors affecting resistance. Now next we will see the unit of resistance. Unit of resistance, we mainly do only the SI unit of resistance. SI unit of resistance is represented using letter capital R, and the SI unit of resistance is ohm, OHM, and it is denoted using a symbol ohm like this. And this is a Greek letter which is omega, but we don't say it as omega, we say it as ohm only. Okay, omega is the Greek letter, this letter is omega, and we call it as ohm, OHM. Now higher units are there, like kilo ohm. So 1 kilo ohm, that is K ohm, it is equal to 10 raised to, kilo means 1000, so 10 raised to 3 ohm. Then 1 mega is represented using M, capital M, mega ohm is equal to 10 raised to 6, mega is 10 raised to 6, so 10 raised to 6 ohm. So higher units are there for resistance, and it is represented, the unit is OHM, ohm, represented using Greek letter omega. Now the last topic of the section is conductance. So conductance, it is actually the opposite of resistance. That means resisting means to oppose. Conductance means to conduct, or to make the flow of current easy. That is conductance. So simply we can say the conductance, or define conductance as the reciprocal of resistance. Reciprocal of resistance is called. So if we are asked to write define conductance, what will you write? It is conductance is the reciprocal of resistance. So in equation form, how will you write? You can write it as conductance is equal to 1 by resistance. Reciprocal means 1 by. So 1 by resistance. If R is the representation, you can write it as 1 by R, 1 upon R. That is what? Conductance. Now if you look at the unit of conductance, what will be the unit of conductance? We know it is 1 by R. Unit of resistance is ohm. So 1 by ohm will be the unit of conductance, and 1 by ohm can be written as ohm raised to minus 1 or negative 1. So ohm raised to negative 1 is the unit of conductance. It is the unit of conductance, and sometimes it is also written as mho, MHO, that is reverse of ohm, OHM, instead of that MHO, mho is used, but nowadays we don't use. The more scientific way of representing the unit of conductance is ohm raised to minus 1. But if you see mho somewhere, it is also used as the unit of conductance. It also means ohm raised to minus 1. So that is for today. We will see about Ohm's law and some experimental verification of Ohm's law in the next class.